Okay, you're given these two functions, y equals 3x squared, y equals negative 6x squared plus 18x, which are two parabolas, one opening up, the red one, and one opening down, the blue one. The points of intersection are at 0, 0, and 2, 12, which you can find by setting 3x squared equal to 18x minus 6x squared, solving that quadratic equation. We're going to revolve that purple region around the line x equals 0, the y-axis. Okay, and you're told to use the cylindrical shell method. So when you use the cylindrical shell method, you have to know three things. First of all, you have to know that a typical shell is parallel to the axis of revolution. So here's the green dashed line. Here's a typical shell, this black shell right here. And the formula for the shell method requires you to understand what the average radius is. So as we're picturing these typical shells moving from 0 towards this 2, the distance from the axis of revolution to the center of that shell, we label x. That's just this distance right here. The height of the shell is the height of that black shell. And we can find that by saying y coordinate at the top, which would be this negative 6x squared plus 18x for each x between 0 and 2. Take away this value right here, which is the y coordinate at the bottom of the shell. So there's the setup of the integral. We will distribute that x and put the, this would be x cubed, 18x squared, getting ahead of myself, minus 3x cubed plus 18x squared. And we'll combine these two terms. Find the definite integral from 0 to 2 and multiply that by 2 pi. Okay, and here is that integral right here in terms of g of x and f of x. It's like it evaluates to 75.398, which an exact value is 24 pi. So when you evaluate this integral right here and then multiply by 2 pi, that's what you get, 24 pi. Okay, I'll leave the work for that to you. I will share my screen real quickly so you can see what's happening on this graph right here. Just wanted you to see the typical shell moving from 0, 0 towards 2, 12. The shell is getting taller. And that shell is getting revolved. Each shell is getting revolved around the axis of revolution. That's why it's called a cylindrical shell. That's what you end up with, a shell with a hole in the middle, but you add all those volumes together, you get the volume of the solid that's generated. There you go. Hope that helped. If you have any questions, post a comment.